Welcome to the session Network Planning for Microsoft Teams. My name is Thomas Binder. I'm a Senior Program Manager in the Teams product group. Before we go into the content, let's do a bit of housekeeping. You can find more readiness modules at aka.ms/Teams Academy. If you have any feedback for this session, if you think there's something that we could explain better, or if you want something else to be explained, please go to aka.ms/Teams community, create a new post, and use the IT Pro training label. We will monitor for those and then respond to you there. If you have any feedback on how Teams behaves, any feature requests, please go to aka.ms/Teams feedback and create an item there or vote on existing ideas. Please be also aware that Teams and Office 365 evolves constantly. So there will be new features, and that also means that there might be a small difference between what we tell you in the training and what's available, because new features might be coming. So please get sure that you go to aka.ms/Teams blog on a regular basis and follow our announcements. You can also see on this slide when we recorded this presentation, and that should give you a good idea how much it is still up to date. The session will provide the following key learnings that will help you to plan your network for Teams. First, connect to the Office 365 network as directly as possible. Second, plan and provide for sufficient bandwidth. And then finally, you need to check each individual site for network connectivity and quality. Please also note that the monitoring of network and media quality, once you have deployed Teams, is not covered in this session. I want to point you here to aka.ms/Teams-quality for a session on Teams quality. We are going to cover the following topics. First, we will be speaking about the Teams networking requirements. Then we will follow with a deep dive on real-time communication. We'll talk about media flow, then live events, which are special from a media perspective in Teams. Then we will double-click on the Office 365 network. And finally, we will talk about quality of service and tools for network planning. Teams networking requirements. In order to better understand why networking is so important for Teams, let's start with a scenario where we have a bad meeting experience. So this is Alice. Alice works for Contoso. Contoso is a very secure company, and they have an old security infrastructure. So they have centralized internet egress, they have proxy servers, they have firewalling whatever they can, they do deep packet inspection, whatever you can think of, they are doing it. So now Alice is attending an online meeting. And because of this networking configuration in her company, the experience is not great. So she might not be able to see people on the video, she might not be able to follow an online presentation, she might not even be able to hear people, which means Teams is pretty much useless to her, and she can't be as productive as she should be. She's losing precious time, she's maybe missing some important details, so she's having a bad experience and she can't do her job very well. Now let's take a look how it looks like with an optimized network. So this is Carol. Carol works in Contoso's IT department. Recently, she learned about how the Office 365 network works, why it can be trusted, and how Contoso's network should be changed to match the strategy and the recommendations of Office 365. They're investing some time, they're doing the due diligence to understand how security works, how trust works, who they can trust, who they should trust, and which kind of traffic patterns they need to enable and improve. They are implementing all of that, and now Alice again attends an online meeting. And because now the network is optimized for Office 365 and for Teams, the quality is fantastic. Alice has a really productive meeting, she sees everyone, she hears everything, and she can do her work much, much better and is a much happier end user. When we're talking about media quality, there are actually a number of influencing factors. From left to the right, the first one is the environment. If someone is sitting somewhere where it's very loud, then it's likely that others on the call, that they hear this noise and that they might be distracted. The same goes for the video. If I'm sitting in front of a background that's very busy, where we have a lot of movement, then it's also more difficult to concentrate on what's happening, and it will also affect how bandwidth will be used. Then the second one is the device. No matter how silent the environment is or how good your network is, if users are using a device with very bad quality that has very bad speakers or very bad microphone or a very bad webcam, then also the quality of the meeting is not very great. Then on the very right side, we have the network. The network is about how is the end user connected to the Office 365 network, what's the quality of the network, and how much bandwidth do they have. In this session today, we are going to focus only on the network and how you can plan for the right network. If you're interested in the other factors as well, please go to ak.ms/teams-quality. Let's talk about the Office 365 network. Later in the session, we will have a section on it and go much deeper. But here, for the introduction, it's important to understand that the Office 365 network is a global network that's provided by Microsoft. We have global worldwide peering points so that customers can connect as closely to our network as possible. And this network is optimized for all the Office 365 workloads. So we know what kind of Exchange, Teams, Skype for Business, SharePoint traffic we're going to have. And we built the network to support it so that our end users, our customers can have a great experience. It's important so that customers can leverage it, that they connect as directly as possible to the Office 365 network. So they should leverage local DNS resolution so that they are always pointed to the most local instance of the Office 365 network. They should reduce latency as much as possible on their internal networks, and to do that, avoid centralized internet access. We provide different Office 365 traffic categories that allow different routing per category. So there are only very few types of traffic that we ask you to route as directly as possible. Traffic that is not as sensitive to latency, you can just keep routing them as you are today. And we'll go into that into a little bit more detail as well. Also, we're not asking you to change your routing to the public internet for all the content that you're getting from the public internet. It's really just the traffic that goes and comes from Office 365 that we want you to consider changing to go as direct as possible. It's also important to keep your networking configuration up to date. So from time to time, we might add new IP ranges or remove some, and we are documenting this at ak.ms/Office 365 endpoints. And depending on what network equipment you have, you can leverage automatic configuration, or you can subscribe to an RSS feed so that you always stay up to date. If you want to go much deeper, there is an Ignite session that I want to recommend. It's called Strategies for Building Effective, Optimal, and Future-Proof Connectivity to Office 365 that will delight your users. And you can find it at ak.ms/BRK3000. So let's talk about these Office 365 categories. There are three categories. They are called Optimize, Allow, and Default. If you go to our website where we list all the IP and port requirements, for each of the entries there, you will see what kind of category it is. The Optimize category is the one that is most sensitive to any latency and needs unimpeded network connectivity. So it is very important to bypass any proxy servers, avoid any network SSL breaks, inspection devices, hairpins. We highly recommend to provide direct internet access so that the traffic can go from your end users as directly as possible to the Office 365 network. That means if you have a branch office, for this optimized category, please allow direct access from the branch office to these clearly defined IP ranges so that users have a great experience. Also, only very few IP ranges are part of the optimized category, and they are limited to Exchange, SharePoint, and Skype for Business and Teams. So we're not going to ask you to open a lot of ranges. It is really a very small number. The next category is the Allow category, which still benefits from low latency, but doesn't require it. You should still bypass any SSL break and inspection device to avoid any proxy authentication that might prevent connectivity. Additionally, we recommend to bypass proxies, network hairpins, and network intermediary devices. In Office 365 connectivity, most of the IP ranges are actually part of the allow category. Then finally, there's the default category, which is for all the other Office 365 IP ranges. For them, you can just leverage the default internet egress. You don't need to do anything special. When planning for networking, don't forget to think specifically about your remote users. If you have remote users and they don't use VPN, well, then they will by default connect to the Office 365 network as directly as possible. However, if you require your external users to use a VPN when working, then you need to consider the Office 365 network. Please enable split tunneling for these external endpoints so that the VPN users can still connect to the Office 365 network for all the traffic that should go there and send only all the other traffic to your VPN tunnel through the tunnel. This way, you can avoid any hairpin traffic, any double encryption, any attempts to inspect the traffic. If you don't do that and force users to send all their Office 365 traffic via the VPN, then these users might have and will have a bad experience using Team. This slide talks about the dimensions that you need to plan for when we talk about network planning. The first one is about the connectivity to the Office 365 network. Can I connect at all to the IPs and the ports? Can all my users establish this connection? They need to, otherwise they won't be able to use all the features. Also, how is my traffic routed to the Office 365 network? Am I going as directly as possible, or am I adding unnecessary latency and delay by going via some central hub? The next dimension is the quality of the network. What is my latency, jitter, and packet loss on the network? And we're going to look at these categories in a little bit deeper later in the session when we do the deep dive on real-time communication. And then finally, it's about the availability of bandwidth. It's fantastic if my users can connect. It's fantastic if they connect as directly as possible. It's fantastic if there's low latency, jitter, and packet loss. But then if there's not enough bandwidth, then users will still have a bad time and will have problems, especially with real-time communication. When planning for the IPs and ports to the Office 365 network for the Teams client, it's important to keep in mind that Teams is built on Office 365. So Teams is in the background using SharePoint, OneDrive for Business, Exchange, and many other features. So it's super important that you meet the network requirements for all these technologies. Otherwise, users might have limited functionality or not be able to use Teams at all. From a pure Teams perspective, the traffic that's exclusive to Teams, there are two types of traffic that we are going to look at. The real-time media traffic and the non-media traffic. And media traffic is audio, video, desktop sharing, everything that you're doing in a call or a meeting. Please note that this is the only type of traffic that's in the optimized category for Teams. So all the other traffic is in the allow or default categories. We're using 4 UDP ports, 3478, 3479, 3480, and 3481 on UDP for these traffic types. We're using only 2 IP ranges. They are listed here on the slide. So this is really the only IP ranges and ports where you need to open the most direct type of connection. It's important that proxies, traffic shapers, other networking optimized devices are not in the path of this traffic, because they might be doing things like not allowing the UDP traffic and forcing it to 443 TCP, introducing additional latency or break the media connectivity. So all of these devices need to be bypassed for the optimized traffic. The non-media traffic, well, that's all in the allow and default categories. And you can find a complete list of the types of traffic if you go to aka.ms/office/o365 endpoints. We have documented the performance requirements that your network needs to meet for optimal media quality. You can also find them online at ak.ms/performance requirements. The metrics are latency, packet loss, and jitter. If you're not familiar what this means, don't worry. We're going to cover that in the deep dive. Also, we're listing here the values. If you don't know yet how to measure these values, again, don't worry. These will be covered. We will be covering tools in the end of the session, on the end of the session, that will help you to measure the performance of your network. In order to provide great quality to your end users, you also need to consider the Wi-Fi. Most wireless networks were not designed for real-time communication. They were put in at some point of time so that people can browse the web and get their emails, but not necessarily that they can do audio-video calls and meetings. So it might be necessary that you reevaluate and improve your network. There are a number of important planning factors, and the most important recommendation is really to follow the guidelines from your wireless vendor. They usually know very well how their network should be designed for optimal coverage and for best user experience, and they can share guidance and best practice on how you can do that. Planning factors include, but are not necessarily limited to, implementing quality of service or Wi-Fi multimedia for the media traffic, to plan and optimize the Wi-Fi bands that you're using and the access point placement, implementing band steering if you have dual band Wi-Fi, so that dual band clients using the preferred 5 GHz range, and avoiding signal overlap by using different channels for access points that are placed close to each other. It's also a good idea to educate end users how they can contribute to great quality in terms of networking. The first area is Wi-Fi. Users should always prefer a wired connection over a wireless connection. And I know this can be hard sometimes. A lot of laptops don't even have network ports anymore, but I've myself experienced this multiple times that I was, for example, in a hotel with a very bad wireless, but where the wired connection gave me a great experience and I had great Teams meetings. Also consider the wireless reception. So if you're in a spot with very bad reception, try moving somewhere else. It might help you having your good quality. Also choose the Wi-Fi network wisely. In hotels, airports, sometimes you have multiple options and some networks might be better than others. For the internet from home, if your users are doing a lot of home office, working from home, get sure that they have sufficient up and download and that they leverage a provider that has good peering with Microsoft so that the traffic goes as quickly as possible from their location to the Microsoft 360, to the Office 365 network. And while you cannot tell your customers, your end users, what network providers they have to use, you can still help them making recommendations. If you're living in an area where some internet provider have a very different peering from others, then you can point out to your users which they should prefer. We also have some more information on end user educations beyond networking in our Teams quality session. You can find the link here on the slide. Now we have covered from a high level everything that you need to provide a great network. However, keep in mind that you need to do this for every new network site that you are onboarding. So a new office is getting Teams, is getting enabled for telephony maybe. You need to do the bandwidth planning there. You need to test the network there to get sure that not only in your main offices people have a great quality, but also in these locations. Also, don't forget to educate your users. The other part is about the keeping it green. So far we have talked about what do you need to plan for great quality, but then there's also the part on, well, how do you get sure that the quality stays good? How do you get sure that there is no a change drift where firewall policies are changed and suddenly quality is dropping? We highly recommend to implement the role of a quality champion, a person that's dedicated to drive the quality, who monitors quality on an ongoing basis and is an escalation point in case there are quality issues. In our Teams quality session, link is on the slide, you can learn more about this quality champion role. Real-time communications deep dive. Let's talk about why real-time communication is special. Real-time communication is used for the real-time workloads, audio, video, and desktop sharing. So it's used in meetings and in calls so that I can transmit my voice, my video, and what I'm sharing on my desktop. This content, this type of traffic, is very sensitive to delay. If I say something, I need the other person to hear it as quickly as possible so they can reply and we can have a natural conversation. Also, I want them to see me in real time, and if I want to show them something on my desktop, I want to point at it, talk to it, and want to see them as I'm showing it to them, and I don't want to have any latency or delay there. That's why in real-time communications, people often say it's better traffic arrives never than late. For natural conversation, we need to have very low latency, as just mentioned. If we lose some of the packets, some of the information, usually we do not really need to care about it. Audio and video might experience some glitches, but the session continues. So if I'm talking and I lose only very few packets, the other end might not even hear some audio glitches or might hear some minor audio glitches, but as long as they can still understand me, we can have a good and productive meeting. If we would be waiting for any of the packets to be resubmitted, now we would have latency, and now we would have a bad experience because it's not a natural conversation anymore. So if we're looking at using TCP traffic or UDP traffic for sending the media, then we need to keep in mind how UDP and TCP work. TCP requires each packet to be acknowledged by the receiver. So if I'm sending now a packet to another person, the packet goes over the wire, the other person receives the packet and sends back to me a message that it received the packet. If I'm not getting this packet, I'm sending it again. This is great because now we're not losing any of the information. All the information will be submitted. This is fantastic if I'm sending any kind of files. However, it also means that if something is lost, there will be, I need to wait for the acknowledgement of that packet. Now I don't get it, so I need to send that packet again. Now I'm waiting again for the acknowledgement, and now that takes a lot of time, a lot of overhead. UDP is different. UDP is just fire and forget. I send out all the packets to whoever I want to send it to, and they receive them. And if we lose a packet on the way, I will never know as the sender. So I'm just sending them, and they will be receiving them. In terms of real-time communication, this is actually the preferred behavior. I'm sending the traffic as quickly as possible. They are receiving it as quickly as possible. And if we lose only a few packets, well then hopefully the effect is not even noticeable, or there might be, again, a few audio glitches, but the conversation can continue. Only if packet loss is too bad, then I can't have a conversation anymore. But in that case, it's a bad network that can't be used for real-time communication anyway, and you wouldn't enjoy using TCP over this network either because you would have so much delay. Teams uses real-time communication as follows. Teams will always prefer UDP for all media scenarios. Audio, video, desktop sharing, we always go over UDP if possible. Even if there's an endpoint behind a firewall that doesn't allow UDP, and this firewall is outside of your control, so maybe the user is at a customer site, or the user is in a public network that blocks all the UDP traffic, then the client will fall back to TCP. We prefer users to be able to do a call instead of not being able to do a call. That's why we're doing this fallback. Also, if there are no other network impairments, the overhead of TCP should be negligible. There's one exception in Teams where you have audio and video and sharing, and it's not over UDP. And that's in the case of live event attendees. Live events, and we're going to cover that also later in the session. Live events are these broadcast events where you have a few presenters, but thousands, actually up to 10,000 attendees. These attendees, they will be consuming the audio and video as a one-way stream. This one-way stream is not sensitive to any delays, and it leverages TCP stream. Well, if there are any delays, they will be just, receive the stream a little bit delayed, but since it's not a conversation where they need to answer and respond, they will have just this delay and shouldn't be noticing it too much anyway. The presenter and the producers of the live event, so the people who are actually presenting, they are still using a regular Teams meeting, so they are using UDP. This slide visualizes the anatomy of a media session. So we have here our two endpoints, two Teams endpoints, and they send media between each other. And if you look at an audio wave, it usually looks something like that. It's basically a wave of audio. In order to get it from one endpoint to the other, we cut this in little pieces of a couple of milliseconds and put the information of each of the pieces into a packet and send this packet over the network to the other side, where it's put together again and they can play back the audio. And this is what it looks like if the network is perfect and there are not any losses. Now, let's look at an example where we experience some packet loss. So whenever Teams recognizes that there is some packet loss, the forward error correction sets in. And the forward error correction means that we will include redundant information into the packets. So as you can see here, it builds now packets with the information of audio part 1 and 2, another packet with 2 and 3, another packet of 3 and 4, and then 4 and 5. And this way, even if we lose a single packet, all the information is still available. So if we would lose the second packet with 2 and 3, the information of 2 and 3 can be retrieved from the other packets. So now these packets are sent to the other client. However, in our example, it gets worse. We lose now 2 consecutive packets. This means now that when we recreate the audio from the information that we retrieved, there's something missing. So 1 and 2 is there, 4 and 5, but 3 cannot be found. In order to provide a good audio experience, the audio healer will try to recreate that packet and will recreate that information. And so even after losing 2 packets and after actually losing information, there won't be a noticeable difference for the receiving party. So as you can see, even though we have some packet loss, Teams can recover from that. And this also underlines the importance of why we're using UDP. Since we're using UDP, these packets are just sent from the sender to the receiver, and if a packet is lost, there's no additional delay, there's no resending of packets, nothing of that sort is happening. We just continue the conversation and have a clear, low latency conversation. If we would be using TCP, these packets would need to be resent, there would be additional delay, and the experience would not be as good as it is with UDP. Let's look at the network impairments in more detail. Packet loss means that some packets are lost or discarded between 2 endpoints. So they're either lost on the way because they're discarded by some routers, or they're discarded at the other endpoint because the packet arrived too late and the part of the audio that the packet belongs to has already been played back to the user. The symptoms are that you might have loss of audio completely or some broken audio. Also, there could be some robotic sounding voice because the audio healer had to guess too much of the information for lost packets. If it comes to video, you might have a frozen picture, or you might just have a lot of fragments, blocks in the video. There might also be delays in your hearing or being heard by the other party. You can limit packet loss by using wired network instead of Wi-Fi, by improving the wireless reception in case of Wi-Fi, or by increasing the bandwidth, always depending on where's the packet loss coming from. When we talk about latency that's really the delay that packages have between 2 endpoints when they go from A to B. And the symptoms are very annoying, people talking to each other. One person talks, makes a pause waiting for the other person to reply, but then there's no reply coming, so the person talks again. On the other side, the person, because there's a delay, when they hear the pause, they start talking, and now you have 2 people talking at the same time, and that can be very, very challenging for a natural conversation. Latency can also lead to dropping packets, because they might arrive too late, and then it will lead to the same symptoms as packet loss. In order to limit delay, again, improve the Wi-Fi reception in case of wireless networks, allow the direction as possible, as direct as possible between internal endpoints, and for the Office 365 network, optimize the routing to go as directly and with as little delay as possible to the Office 365 network. Jitter is when packets arrive in the wrong sequence. So the audio packet with the information that's supposed to be played back later arrives first. So Teams has a jitter buffer, a buffer that is used to reorder these packets into the original sequence. The symptoms of jitter is, well, the jitter will increase latency because, now we need to wait for the earlier packet to put them back into the right sequence. And that means we are increasing the latency, and you will have the same symptoms that you also get from latency. Also, if packets arrive too late, then the jitter buffer will just say, well, I'm not going to wait for this packet anymore. I'm just going to ignore it and consider this packet as lost. So jitter can also lead to the same effects as packet loss. You can limit jitter by getting sure that there is no network congestion and by increasing the bandwidth. Finally, the bandwidth. It is important that you have enough bandwidth for all the information to go through your pipe. Lack of bandwidth will lead to using lower quality codecs. So Teams is smart enough that it realizes, oh, wait a minute, to have a high quality call, we're using this wideband codec, but it uses a lot of bandwidth. So maybe because there is not enough bandwidth, let's switch back to a narrow bandwidth codec. It will lead or might lead to additional latency, jitter, or packet loss because packets are delayed, packets might arrive in the wrong wrong sequence, or they might be dropped altogether. And all of that will impact media quality. In order to plan for bandwidth, you need to look at the number of users and what workloads they are using, and then you can plan for the correct bandwidth that you're using. Later on in the tools section, we will show you the network planner, a tool that takes you through all the steps throughout the planning process so that you can plan for that bandwidth. Only for the live events, for the attendees in the live events, you need to plan separately because that's not covered as part of the bandwidth planner, but we'll point that out as well later on as well. Media flows. In order to understand media flows, we need to understand the different types of calls. In general, there are two different kinds of calls. The one is a direct call. A direct call can only be between two users and needs to be ad hoc. So if you go in your Teams application, select any other user, call them, they pick up, then the media will go as directly as possible between these two users. And it will not go via any service or proxy if network allows it. On the other side, the meeting is everything that has more than two users and or is a scheduled call, scheduled from within the Teams application or from Outlook. If it's a meeting, then there's always a conferencing service involved, and all the endpoints send their audio and the video, and if they are sharing a desktop sharing, to this conferencing service. And then the conferencing service sends to the different attendees whatever they need to see and hear. So it mixes the audio and then sends it out again. Endpoints will connect to this conferencing service directly if the high ports are open. So if I have an endpoint on the internet, they will just go over the high ports directly to this conferencing service that's sitting in Office 365. If the high ports are closed, then the endpoints will connect via the transport relay on the ports that we talked before, 3478 through 3481 UDP. This diagram shows us a one-to-one call between Alice and Bob. So in this case, Alice and Bob are sitting in the internal network behind the corporate firewall on the enterprise network. And Alice wants to establish a call to Bob. So before she does that, there's some signaling that Alice is doing. So she is communicating with the Office 365 cloud, with the Teams services so that she knows if Bob is online and how to reach Bob. And also Bob is signed in. So his signaling is also to the Office 365 cloud. The signaling goes always over 443 TCP. The media, however, will now be established, once they click on the call button, will be established as directly as possible. And this means that all the traffic can stay on the enterprise network. There's no need to do a detour over the internet to the Office 365 network. It will be just peer-to-peer. And that means that there's the lowest latency that we can possibly reach for these users. However, sometimes it might not be possible to send this traffic directly. Maybe Alice is at home and Bob is in the corporate network, and the firewalls, as they should, don't allow a peer-to-peer connection between internal users and external users. So what's not going to change is the signaling. That still goes via port 443 TCP to the Office 365 network. However, as we just said, the peer-to-peer traffic in this example is for whatever reason blocked at this moment. So what Alice is going to do, and Bob, is that they are using a relay to send all the traffic, all the media to this relay. It's called the transport relay. And from the transport relay, then it goes to Bob. In order to reduce the relay and the latency between Alice and Bob, Microsoft has deployed these transport relays all over the world. And they will automatically choose the most local one based on IP routing. And this way we can get sure that the traffic doesn't need to go through half the world before it goes from one user to the other. But it also shows why it's really beneficial in your enterprise network to allow this peer-to-peer connectivity so that you don't even need to go to this relay. Let's talk about meetings. We have already established that meetings are always, all the media is always sent to this conferencing service that's homed in Office 365. In Teams, we will always choose a conferencing service that's in the same region as the first user who joins the meeting. So it does not matter where a user is located who plans the meeting. At the point of time where the meeting is started, the first user to join the meeting, that's where the meeting will be homed. And that allows us to provide much lower latency. Also, international customers on different continents, they don't need to worry where the tenant is homed or where the users are homed. It's all depending at the time when the meeting is started, where the first user who joins the meeting is located. And here we have an example. So in this example, we have a customer. They have their tenant in the US, and in this meeting, only US users are going to join. So we have here some users. They are going. Each of the users will go to the closest peering point to the global Microsoft Office 365 network, and from there, this user is connected to the conferencing service in the same region. And we have more users joining, and all these users, they have now a local meeting. Now, if the same tenant, so this is the same customer, same tenant, but now they have users from Europe who join a meeting. So again, join to the closest Office 365 network peering point. But now, because all these users, well, the first user who joins the meeting is located in Europe, they will have a meeting in Europe and they don't need to send all the traffic around the world. So this is how we can avoid some of the latency that you might experience in other services. Live events. Live events are kind of broadcast meetings. For example, a town hall meeting where the CEO wants to talk to all the people. They support up to 10,000 participants, and you have presenters who can share audio and video and their desktop from within what is basically a Teams meeting. The participants will watch the content, the meeting, in a stream. So live events are a little bit special from a media consideration. The presenters and producers who create the live event, they are just part of this special Teams meeting, but they have the exact same requirements as everyone else who would participate in a Teams meeting. So they have their audio, video, and desktop sharing, and this is sensitive to any network issues. The participants, however, watching this video as a stream, it's not real-time communication. Yes, bad network will still affect them. They will have some delays. They might experience some buffering, where they can't watch the video for a few seconds until it continues, or they will have reduced video quality. But they're not missing anything of the video. They will still be able to see the full video, well, if they have enough bandwidth to watch the full video. So the most important thing for the participants is really that they have sufficient bandwidth for enough people to watch the stream. And keep in mind, if the CEO is making an important announcement, you might have actually a lot of people, even located in the same office, who are consuming the same stream and needing the same kind of bandwidth. Also keep in mind that if the presenters in a live event have a bad experience, if they experience network degradation, all participants will be affected because, if the presenter can't send any audio, no one will be able to hear this audio. However, if one participant experiences network degradation, well, that will only affect that participant, and we don't want that participant to have a bad experience, but it won't affect any of the other users. In order to plan for bandwidth for live events, for the presenter, plan as part of the regular bandwidth planning. That should be included. No reason to specifically plan for that. For the participant, however, you should, as an average per endpoint, plan for 1 to 2 megabits per second. Also, you can use some user education. So, for example, if the CEO wants to make this super important announcement and everyone in the office is expected to watch, well, maybe give people some incentive to go to a big meeting room and watch it on the video wall and do it together there, so that you have this bandwidth only once delivered to the office instead to every individual PC that you have there. The participants consume the live stream delivered by Azure Content Delivery Network, by the CDN. It's part of the global Microsoft network, and we use it to deliver the stream worldwide via local peering points to avoid buffering. But there's also the concept of an eCDN, the Enterprise Content Delivery Network. So Microsoft partnered with a couple of companies so that they can integrate their solutions where for each of the offices only one stream from the internet would be consumed, and then this solution distributes the stream within the company. That means that now you have hundreds of users within the same office watching the same stream. You only need to have the bandwidth from your office to the internet for one single stream. If you want to learn more about our certified eCDN partners, Hive Collective and RAMP, please go to ak.ms/teams-ecdn. Now that we have mentioned the Office 365 network multiple times, let's take a deeper look what it really is and how it works. So let's think about how users connect from your corporate network to the Office 365. Obviously, there's somewhere the internet involved. And a lot of people would believe, well, I have my corporate network, my user sits there. From the corporate network, I go on the internet, and then I have this really long leg from the internet to the Microsoft data center where the Microsoft services are sitting. And that means long time on the internet means there's plenty of opportunities to get any network impairments. However, this is not what's happening. Microsoft runs this Office 365 network. So in reality, yes, you have your corporate network. Your user is sitting on the corporate network and using it. And at some point from the corporate network, the traffic needs to go to the internet in order to come to Office 365. However, Microsoft has peering points to their worldwide global Office 365 network. And they are very close to most of our customers. And we have lots of peering points with ISPs and peerings established. So in reality, the lag on the internet can be very, very short. It can be as little as a few hops if your ISP, if your internet service provider has direct peering with Microsoft. And then the way from your ISP or the ISP that has the peering with Microsoft, to the services in the Office 365 data centers. All of that will be done on the Microsoft network, which is built for zero jitter and zero loss. The latency is only imposed by the distance and the speed of light. And this is part of Office 365, so there's nothing that you need to specifically purchase in addition or configure. The traffic will just go as quickly as possible on the Microsoft 365 network. And this is a diagram of the Microsoft Global Network. You can get more detailed information at ak.ms/Microsoft-network, but it shows you the many connections and peering points that Microsoft actually has. So this is not the internet. This is the network that Microsoft runs specifically to provide great quality to Office 365 customers. Here are some facts about the Microsoft Global Network. It's one of the 2 top networks in the world. It has tens of thousands of privately owned dark fiber. We are connected with 2,700 ISPs in 190 peering locations in 38 countries. 90% of the connected internet population can connect with metrics comparable to Tier 1 ISPs or telcos, with media processors and relays deployed to more than 50 Microsoft data centers and edge sites, and more are being deployed. And all of this is to optimize for media. So it's built to reduce latency, reduce the number of hops, we prioritize audio traffic, and we keep improving ISP peering performance based on our call quality metrics. So if we see that in the telemetry that the call quality is not what it should be, we are going to work with the ISPs to improve it. As mentioned earlier, the meetings are hosted in the same region as the participants, and we have consolidated IP ranges to make it really easy to do the right configuration on your network and firewalls. All in all, you could stretch with the optic network, could stretch to the moon and back 3 times over. To better illustrate the benefit of connecting directly to the Office 365 network, let's see the following example. Here we have a traditional hub internet, centralized internet access. So I have all these green dots here, which represents offices, and here in the lower left corner in Spain, I have my main office. So if these users here want to have a conference, the traffic needs to go in the upper left corner to our data center. But first, because we are using here the centralized internet access, it needs to go to the data center. So they send their audio here to the data center, then it goes to the Microsoft data center, it needs to go back, and from there it can go to all the participants. So this is a little bit unnecessary to go all these wide ways. So let's see how it would look like if we have localized internet access, direct internet access. So now it's still the same office locations, but we don't need to go to this data center anymore. These blue dots are all the Microsoft peering locations. The yellow dots are the ones that we're going to use actually in this example. So we can see here the yellow users in the yellow office, they just have a very close peering locations. They can go directly there, and from there they go over the optimized Office 365 network to the data center. The red one closer than before as well, and the green one also super close. So now they can just send here out the traffic and have him come back again, and now they are avoiding a lot of unnecessary latency just by going directly to the internet instead of going through the centralized internet access. So how can you optimize the connectivity to the Office 365 network? We've seen this diagram before. There's the corporate network, the internet, and the Microsoft network. On the corporate network, you can do a number of things. First, you should provide local breakouts for Office 365 traffic. especially the traffic in the optimized category that we mentioned before, should go as directly as possible. So a local breakout can really help the traffic to reduce latency and to be just super quick on the internet to go to the Office 365 network. Optimize your internal routing. Get sure that you don't send everything to a central location first, or that you don't send your traffic on any detours. This will help not only latency, but also reduce the amount of bandwidth that you are using on your internal network. And allow for local DNS resolution, so that all users can use services as local to their location as possible. So if you do all of that, then the amount of length of the network path that the traffic needs to travel on the corporate network might shrink substantially. For the internet, while you can't control the internet or control your ISP, you still have some influence. You can talk to your ISP to optimize the routing. So first you can investigate how quickly are they routing traffic to the Microsoft network. And if this routing is not optimal, you can ask them to improve that. In general, they should have an interest in getting the traffic as quickly as possible off their own network to the Microsoft network, so that you don't use their resources, but the Microsoft resources are used. In case that your ISP is not willing to work with you and does not provide good peering, there's always the option to go to another internet provider who might give you better services. There's also a database, aka.ms/8075, that lists all the peerings that Microsoft has with the different internet providers. So if you do all of that, now the lag on the internet shrinks as well. The lag on the Microsoft network might actually grow a little bit. Why? Because you're now going less on the not managed internet, but using more the Microsoft network. And that's a great thing because it was designed for Office 365 workloads for real-time traffic. And now this Teams traffic can travel to the Office 365 network much, much quicker. So how does peering work? So the internet is basically a huge collection of routers that route traffic to each other. So you can see here on the very left side, the customer who has Teams, and they have a router that sends the traffic to the internet. Then we have here different ISPs around that. And here in the middle, all these routers, that's your ISP. And it's connected to other ISPs, to other cloud services. In the upper right corner, you can see it's connected to the Microsoft network. So now your ISP sent traffic there to your first to the ISP, to the first router, and now they could send whatever way the traffic. And the more hops they have, the more delay you will experience. So that's one of the ways they could route it. They could route it a different way as well, not as optimal. What you really want them to do is doing a super direct route. And as you can see, this will not only help them saving bandwidth on their resources, but it will help you by reducing the number of hops. So understand how the peering with your customer, with your ISP works exactly, and talk to your ISP to improve it. Quality of service. This slide will introduce you to the concept of quality of service. Quality of service allows you to prioritize different traffic types. So your bandwidth is usually a limited amount, but you want audio and video to be preferred. So you can put audio traffic in a priority queue so that the routers always know, well, if there's not enough bandwidth to send all the traffic through, I will always prioritize audio, so that even though there is not enough bandwidth, people will still have a great audio experience. Then there's video. Let's also give some priority to video, not as much as audio, because if you have a call and you lose audio, that's really bad. If the video freezes once or twice, users might not be super happy about that, but they can still have a great conversation. Other traffic, like web, email, and file transfer, well, they are in the best effort queue. We will try to send them, and if not, then we will just resend it later. This way, the real-time traffic has priority, people have a great real-time experience, and the not real-time traffic will just wait a bit until it's time for it to be delivered. In Teams, you can use quality of service. Obviously, you can use quality of service only on the network that you control. So you wouldn't be able to do that on the internet, but you can use it on your enterprise network. In Teams, the traffic should always be marked based on the client ports. We are using different port ranges for audio, video, and sharing, so that will allow you to assign different policies on the traffic types. And by doing the marking based on the client ports, not only the client to service traffic will be marked, all the traffic that goes for meetings to the Office 365 service, but also the peer-to-peer traffic between clients that are sitting on your network. If they have calls one-to-one, this can also be prioritized then. The traffic should be marked on the network. There are always different options, so you could mark it on the PC, on the device itself, or on the network. But since we have so many different devices that can run Teams, and it can be very complicated to set it on some of these devices, or maybe not possible at all, we recommend that the network, the routers, they just look at, is this traffic from this port range to this port range? If so, then we make the assumption that it's audio traffic from Teams, and then it will get the specific marking. Traffic coming from Office 365 should be marked as well. This is coming from the internet, so it will be coming in without any traffic marking. But then on your network ingress, on the routers to your ISP, you can again look at the client ports and make the determination if this is audio, video, or desktop sharing, and then give it the appropriate tagging. The Teams client port ranges are as following, separated per workload. For audio, we use 50,000 to 50,019. For video, we're using 50,020 to 50,039. And for application or desktop sharing, we're using 50,040 to 50,059. We prefer UDP, but we can follow TCP. So all of this should be marked as you need it by your network. Usually we recommend the DSCP values of 46, that's expedited forwarding. For audio, we recommend 34, assured forwarding. For video, and then 18, assured forwarding for application and desktop sharing. Please note that currently the web clients don't use these port ranges due to limitations of the internet browsers. So traffic for web clients can currently not be prioritized. In general, if you're asking yourself, well, should I deploy QoS? We recommend that if your network is already configured for quality of service, then you should use it, or you need to use it for Teams as well. If you're not using it for Teams, but other applications are getting preferred for quality of service, by quality of service, it means that by definition, your Teams users will have a worse experience than the users of the other services, because the other services are getting priority. If you don't have quality of service, you might consider not implementing it. Quality of service can be expensive to implement and to manage. Instead, you can invest into more bandwidth, because quality of service really helps you only if you don't have enough bandwidth, then it will help you to prioritize the audio video traffic and the desktop sharing. But if there is sufficient bandwidth, then quality of service doesn't have any positive effect. So it might make more sense to invest in more bandwidth than doing a huge quality of service project. Tools for networking. For Teams, we have the following tools for network planning and optimization. The network planner to plan for the bandwidth that you require. The Skype for Business network assessment tool that checks for quality and connectivity from the respective client location. And Traceled, which is not a special Teams tool, but can help you to understand how routing to the Office 365 network is handled in your environment and with your ISPs. The Network Planner is a wizard-driven tool to plan for the required bandwidth. It will ask you a couple of questions on what are your locations, your networks, your personas, how many users, how much audio, video do you expect them to use. Then, based on this information, it will calculate the expected bandwidth requirements and make recommendations. Also, the subnet location information can be exported for the call quality dashboard. So you can later on, once you're running Teams, you can use this call quality dashboard to identify networks and locations where you might have challenges with the network based on the information that you entered here. The network planner is completely web-based. You can find it at aka.ms/network-planner, and it's always up to date. So if if something in the product changes, if a codec changes or requirements, the network planner will always be up to date with that information. The network planner also allows you to configure multiple organizations. So if you're a partner and you work with multiple customers, you can create multiple different profiles there and work with all of these. One thing to keep in mind is that the predicted bandwidth is not always the actual usage. Well, most of the time it probably isn't, but it's a good starting point. It is super crucial that once you deployed Teams, that you monitor the usage, that you look at the call quality dashboard and understand what the real qualities that users are experiencing. But in order to be set up for a good start, you need to do the network planning. This is what the network planner looks like. So if you go to the URL, then you have the network planner, you have the introduction, it tells you what the network planner is, that you need to complete your profile and environment, that you need to describe your network use, and that it will give you the recommendations on what you should do and how much bandwidth you should need. This is an example of the site information that you enter. So you can enter a site name, for example, Vienna. You can give it a building name, a location, a country, a user count, and this will help you to make all the calculations for your bandwidth planning. The results look something like that. Again, we can see here Vienna, we can see the type of network, our WAN, our Office 365 network, the WAN being used for the direct calls peer-to-peer, the Office 365 being used for our meetings because that traffic directly goes to Office 365. We can see how much audio, video, desktop sharing, and so on, how it is used. Also, you will get some recommendation if you have sufficient bandwidth or if you need to have more bandwidth there and need to add additional bandwidth. The Skype for Business Network Assessment Tool, even though it's called the Skype for Business Network Assessment Tool, is fully compatible with Teams. It is a command line tool to test call quality and connectivity. You can find it at aka.ms/NWA tool, and you need to run it from the specific location that you want to test. So you go to the network, you take a client, you install the tool, and you run the tool there, and you will know exactly what the network experience for this particular PC will be if they would be joining a Teams call. There are two kinds of tests that you can run. The first one is for testing the network quality. So you just run the tool and it will conduct a real audio call in the background for 17 seconds against Office 365, exactly like a user would be in a call. And then it will report a couple of metrics: the round trip time latency, the packet loss, and the jitter. So if you remember when we had before in the beginning, the network metrics that you need to meet from a location for optimal media connectivity, this tool tells you exactly if you're meeting these values or if you're missing them and if you need to improve your network. The network assessment tool can also check for connectivity. If you start it with /connectivity check, then it will try to connect to all the different relays on all the different ports and will report back if it can connect or if it can't. We change our relays from time to time. We add new relays, we might remove some. The list of relays that are tested is always up to date because it retrieves this information at runtime. So this is a good test from a client, from an endpoint, to check if the firewall is configured as it should be and as expected. Finally, Traceat can be a very good tool. It's a command line tool built in Windows, and it allows you to see how traffic is routed. Please note that there might be some specific traffic configuration, some network configuration, where Traceat packets might use a different path than Teams. So maybe your company has configured the network that only the Office 365 optimized traffic is routed directly to the internet, but not the tracer traffic. In this case, you might actually not see accurate information. But you being the network administrator, you should be probably able to figure out if only tracer is showing you a weird routing pattern, or if it applies to the Teams traffic as well. The recommendation would be to run this against any IP in the Office 365 network. So you could, for example, run it against world.tr.teams.microsoft.com to run it against the transport relays that we use in Teams. And then you should be able to see the number of internal hops that the traffic takes on your internal network, and that will help you to optimize your internal network. Again, before you make claims that your internal network is broken, get sure if the Teams traffic indeed uses the same path as the tracer traffic. Then look at how many hops do you have on the internet. And this is where your ISP can help to optimize by reducing the number of hops that you have on the internet. Here is an example of a tracered trace. So we did tracered to world.tr.teams.microsoft.com to see how many hops do we have to reach these transport relays. First, you can see the local router. Then you can see the corporate and provider networks. And this is really where you want to concentrate your investigation on. Are there any internal networks where you could optimize? Are there any external networks where you can ask your ISP to optimize? Are they using 27 different hops to 2 different continents before they go to the Microsoft network? Or is this really direct and they have already done what they can do? Then somewhere there will be the Microsoft Edge, and you will be usually able from the name to understand that this is a Microsoft network. Then you have the Microsoft network itself, and that's hidden. We wouldn't disclose that information, but then eventually we would reach the transport relay. So let's look at the summary, what we have covered today. The key learnings are that in order to provide great media quality to your end users, you need to plan and provide sufficient bandwidth. Also, you need to connect to Office 365 as directly as possible. That means you need to optimize your enterprise network to get sure that you avoid any centralization, any detours, any hairpins, all of that kind of sorts that might just introduce latency and increase the chance that something, that network impairments happen to your traffic. But also, you need to reduce the time on the internet as much as possible by working with your ISP and getting sure that they route the traffic as quickly to the internet as possible. Ultimately, you need to check each of your sites for network connectivity and quality. You need to run the network assessment tool to get sure that there is low latency, low packet loss, and low jitter. With the combination of having a good quality network to Office 365 and sufficient bandwidth, your users will have really great quality. Thank you for attending today's session.